So before we even start this word problem, just make sure that you comprehend everything that's going on here. We've got a fish jumping out of the water, and we're given his equation of the path that he takes as he jumps out of the water, and we're told that x is time in seconds and f of x is how high up out of the water he is. So I'm going to go ahead and label that stuff. My x values are time in seconds, and my y values are his height in feet. Okay, then we also have this beautiful eagle up here. He's sitting on the top of the cliff, and he sees the fish jump, and he's going to swoop down to catch the fish. So we've got his path, and they give us the equation for his path and tell us that x is also time in seconds and g of x is height in feet. So they're both having x values of time and y values of height. Now on the questions, they're going to ask me, number 4, what's the fish's maximum height? Really what they want to know is, what are the coordinates, what is the y coordinate of the vertex? And the reason it's just the y coordinate is because it only asked me for his height, not when he reached his maximum height, but what is his maximum height. So let's put the equation for the fish into the calculator. His equation is the negative 0.3x squared plus 3x. And let's look at his jump. And I need to know the y value of the vertex. Now you can see that the vertex is a maximum because it's the highest point on the graph. So I'm going to calculate the maximum, choice number 4. And I'm going to set the left bound a little bit to the left of the vertex, and the right boundary a little bit to the right of the vertex. And when it says guess, I'm going to hit enter one more time and see that the maximum is at 5,7.5. So I know this ordered pair is 5,7.5, meaning in 5 seconds the fish was at its maximum height of 7.5 feet. So the question is, what's the fish's maximum height? 7.5 feet is the highest that the fish reached. And number 5, how many seconds will the fish remain in the air? So the fish is in the air from here all the way until he enters the water again right here. So what they're asking me is, what's the x value of this point right here? And the reason I know it's x value is because it asks for seconds, and this is when he leaves the air and goes back into the water. So what I need to know is where this parabola crosses with the x-axis, and I can go ahead and use my calculator to get that answer. I'm going to enter the equation of the x-axis, which is just y equals 0. So I'm going to enter my second equation. Here's the fish's equation already in here. Second equation, y equals 0. And then I'll ask my calculator where these two lines intersect. So second, trace, this time selection number 5, intersect. And I'm going to hit enter 3 times. And I should have seen that one coming, but it gave me this intersection. That's when the fish left the water. I need to know this one. I may have to zoom out a little bit, but I'm going to try to find it without doing that. So before I start hitting enter, I need to bring my cursor over to that side. Let my calculator know I want to know the one on this side, not the other one. So once I get it closer to the intersection on this side, enter, enter, enter. And put me right back to this one because it can't see where this is actually crossing. So I was trying to be lazy and not change my window, but guess what? I need to change my window. Instead of my x max ending at 10, I'm going to end it at 20 so I can get a picture of this. Alright, try it one more time. Calculate the intersection. There we go. I probably should have, I was afraid it was going to drop me back to this one again. I probably should have moved it closer to this one first, but it went over there to that one. So my intersection at 10, 0, means that at 10 seconds, the fish was at a height of 0 because he was coming back into the water. So how long did he remain in the air? 10 seconds. So now on number 6, they want to talk about the bird. From what height did the bird begin his descent? So the bird is up here on the x-axis. Sorry, y-axis. I know that's the y-axis. The bird is up here on the y-axis. And what we want to know is how high up he was. We want to know the y-coordinate of where he is actually, where his path is crossing the y-axis. So if I put his equation in, I'm going to trade him for equation number 2. I'm going to take that 0 out and put him there. His equation is the 0.5x squared minus 10x plus 25. Okay, so he is 0.5x squared minus 10x plus 25. And if you look at his graph, there's the fish. Here comes the bird. You can't see where he's actually touching on the y-axis, but you could go to the table. Now remember, he was equation number 2, the bird was, so you're looking at these values, and you're trying to find when x is 0, what's y, because that's the y-intercept. So the bird was up 25 feet. That's how high up the cliff he was, 25 feet. And again, I found that by finding when x was 0, what y was. This equation is the fish. When it was 0, the fish was just coming out of the water. He was at 0 as well. Okay, so we decided the bird was 25 feet up in the air when he began to swoop down on that fish. How deep into the water did the bird dive? This is how deep into the water he dove. That's his lowest point, which is the vertex. So if we want to know how far into the water he was, now we're not asking how long he was in the water, how far. So what we want is the y-coordinate of this vertex. So for the fish's equation, I'm going to calculate the vertex. Second trace, and his vertex is a minimum, so 3, and I really need to see it, so I'm going to change my y minimum, and instead of being at -10, I'm just going to go down to -30 and make sure I get it on the first try. So now I'm going to calculate the minimum, number 3, and I'm just going to pull my left anchor a little bit to the left of the vertex and the right one a little bit to the right. And when it says guess, I'm going to hit enter one more time, and I'm going to find that this one has a vertex at 10, -25. So the vertex here is 10, -25, meaning after 10 seconds, the bird was at -25. Now, for our purposes, we would never say he dove -25 feet into the water, because negative feet doesn't make sense. How deep into the water did he dive? He dove 25 feet into the water. How long did it take the bird to enter the water? So to answer this question, you have to know, when did the bird enter the water? He entered the water right here. So in other words, this is one of the solutions where this parabola is crossing the x-axis. So I'm going to find on the bird's equation, when x is 0, I'm going to go ahead and put the x-axis equation in there, and I'm just going to intersect those. So second trace, and this time I'm going to find their intersection. And I want to know this one, because the question was, how long did it take him to enter the water? This one represents the bird coming back up out of the water. So this is the one I want to find. So I'm just going to get right over there next to it and enter, enter, enter. And it tells me that this intersection is at 2.9, I'm going to round it to 2.93 comma 0. So this point, 2.93, comma 0. The question is, how long did it take for the bird to reach this point? The answer is 2.93 seconds. So almost 3 seconds, but I would go ahead and leave it at 2.93 seconds. And then finally, at what ordered pair, so this time we need the x and the y value, did the bird catch the fish? So the bird really stood 2 different times that he could have caught the fish, here or here. And it doesn't really specify which one they want, so I guess if he missed here, he could have caught it here. I'm going to go ahead and list both answers. So we already have the bird's equation in. I'm going to put the fish's equation back, and I'm just going to calculate where the 2 equations intersect. So the fish was the negative 0.3x squared plus 3x. And when I look at these 2 equations together, there's the fish, there's the bird. And I'm going to calculate first this intersection and then this one. So second, trace 5. I'm going to let my calculator know, I'm moving the cursor to this one, and let my calculator know that that's the one I'd like to know first. I'm hitting enter 3 times, and my calculator says that this one is at I'm going to round it to 2.9, comma, and this other one, 5.196, I would round that to 5.2. So after almost 2.5 seconds at 5 feet, a little more than 5 feet up in the air, that's the first opportunity the bird had to catch the fish. The second opportunity is here. So second, trace 5, and move that cursor over to that other point of intersection, otherwise you'll do what I love to do, which is find the one we already know. Once you get it there, you're going to hit enter 3 times. Doesn't have to be right on it, it just has to be closer to that one than it was to the other. So his second chance happens at 14.02 seconds, comma, negative 16.91 seconds. So there's his second chance. I didn't realize I didn't have that where you could see it, but I hope that this makes sense to you. I was showing you how to work it. I just wrote the answers down here. Again, the best advice we can give you on these types of problems is before you even start answering the questions, just know what each of the graphs represents so you can figure out what you're trying to find.